Hello again, my name is Al Palmer. I'm from Montcalm Community College and I'm trying to fill in some of the content that might make doing your learning activity packets from Amatrol a little bit easier. So I'm going to discuss Learning Activity Packet 2 right now, and it has many skills that you're supposed to walk through, and they're trying to get across to you a concept. And I'm sure they're presenting this concept in the material in the best way that they can, but I want to supplement that a little bit. And what they're having you do in Learning Activity Packet 2 is measure voltages and current. And you have to have a good understanding of what voltage and current is. And so there's a lot of analogies you can do when you're describing electronic circuits or electrical circuits. And the problem is you can't see electricity. If we taught this with hydraulics or pneumatics or any other medium, you could see pressure and flow rates and all that kind of stuff. But when you're dealing with electronics, if something's got 20 volts, you can't tell by looking at it. You have to trust the numbers that are on your voltmeter. Now, they have you use this multimeter in three different modes, and you need to understand what this meter is doing. And so this is actually like 4 meters in one. It's a voltmeter for AC and DC. It's an amp meter for AC and DC. It measures continuity and it also measures resistance. And so I'm going to just try and get you to understand the three concepts, the three variables that we use in electronics. And that's voltage, current, and resistance. And you know them as Ohm's law that says E equals I times R, or if we use these, it's volts equals amps times resistance. Some people put them together as a thing like this, and it looks like this, and you cover up the one you want to know. This tells you the algebra. R is equal to volts divided by current, amps is equal to volts divided by resistance, and volts is equal to amps times resistance. And so it's the three versions of Ohm's law, V, A, and R, or E, I, and R, where E is the same as volts, I is the same as amperage, and R is the same as resistance. And you can use these interchangeably. I'll try and stick with V, A, and R, although I'm more familiar myself with E, I, and R. However, here's what we're trying to get across. If you have a power supply, and let's use your car battery as an example, it's 12 volts, okay? How many amps can it put out? A lot. The car battery can put out 200 amps if you hook it to the correct load. Starters in a car typically draw 100 to 150 amps of current to turn over a motor. So when you're measuring voltage, you can take a voltmeter, put this on volts, and put it directly across a power supply like this. Why? Because a voltmeter has very, very high resistance. As a resistor, a voltmeter looks like 10 million ohms. It's a lot of resistance, and so when you're making this measurement, very little current, I'm signifying with an arrow, is flowing out of the meter. You can flowing out of the power supply. You can measure this voltage for years without drawing that power supply down. It just takes a very little small sample. Remember, voltage is similar. Voltage, if you were to use a hydraulic analogy, is the same thing as PSI. It's pounds per square inch. It's the amount of pressure that's being pushed on the electrons as they go through the circuit. And so if I have 12 volts here, that's not a lot of pressure. Current is equal to the flow rate. How many electrons are actually flowing through the wire? If you could see this, it would be like how much water is flowing through a pipe. It's possible to have a lot of pressure on a pipe with no opening, no valves open, and have no flow rate at all. If you have a car in the parking lot, you got a 12-volt battery, and hopefully there's no flow coming out of your car battery at all. If you left your headlights on, then perhaps your battery is discharging and there is some flow out of your battery through the headlights. How much flow? To measure flow, you actually have to break the circuit and insert the amp meter into the circuit and force the current to flow then through the amp meter. When you switch this meter to an amp meter by going like this, AC amps and DC amps, depending on what you're trying to measure. You have now changed this from being 10 million ohms to 0.1 ohms. Why? Because you want as much flow to go through this amp meter as possible. And you don't want the meter to add to the resistance of the load. So if you have a load in a circuit, you typically put the load in parallel with the power supply. I'll use a resistor symbol here. You have current flowing through the resistor, and you can measure that current flow with the amp meter. This is measuring how many electrons pass a point at in 1 second, and this is measuring how much force is being applied to the electrons to force them through the load. So this device here is now behaving completely different than the same meter hooked up as a voltmeter. Because as a voltmeter, like I said, it's 10 million ohms, and as an amp meter, it's 0.1 ohms. We blow a lot of fuses when we do this lab, and here's why. People will take an amp meter and hook it up to a power supply like this. Now, what you've just done is you've put 0.1 ohms right across the power supply. If I plug it into Ohm's law, amps equals volts divided by resistance, I get 12 divided by 0.1 is 120 amps. That's enough to destroy the power supply and the meter. So hopefully the fuse blows before any of that happens, and you only have to take the meter apart and change the fuse. So the point I'm trying to make is, when you want to measure voltage, you can stick a voltmeter directly across the power supply. When you want to measure current, and you put the voltmeter in parallel with your load, when you want to measure current, you have to break the circuit and insert the current meter in series with the load. When you flip this meter over from being a voltmeter to an amp meter, not only do you have to change the range, but you also have to change the input connectors from common in volts to common in amps. And our labs will be using the 10 amp range right here. So make sure when you're measuring current that you have a load in the circuit and the amp meter is in series with the load. And when you want to measure voltage, your voltmeter is in parallel with the load. And make sure the meter's leads are connected to the right input jacks. Now, if you put this on amps and you plug the meter leads into the wrong holes, hopefully this meter will alert you and tell you that you're on the wrong range. And so you have to go to the right range, and then the meter is saying, okay, you can make your measurement. That was enough time to blow the fuse if I had the circuit incorrectly wired. And so you have to have your instructor check your circuit and make sure that your amp meters are hooked in series and your voltmeters are hooked in parallel with whatever measurement you're trying to make. Thank you.